Hi, I'm Paul. We are doing the Leetcode must-know interview questions. Today's challenge, number 918, maximum sum circular subarray. What did we do yesterday? Maximum subarray. It's interesting that there's so much difference between the numbers here, the 53 and 918. But the challenge is, actually, let me see, what are the topics for this? Monotonic Q. Don't think I was really going to Q anything. Dynamic programming, divide and conquer. I'm not sure most of those even apply. This is listed under the Kadane's algorithm category, which is probably more appropriate. Anyway, here's the challenge. Given a circular integer array, nums, of length n, return the maximum possible sum of a non-empty subarray of nums. Okay? The last one that we did was just an array. Okay, not a circular array. What is a circular array? Well, that means that the end of the array connects to the beginning of the array. Formally, then, and that means, you know, the following explanation will be hard to understand. The next element of nums I is nums I plus 1 mod n. And the previous element of nums I is nums I minus 1 plus n mod n. Yeah, okay. Well, let me read the rest of it. A subarray may only include each element of the fixed buffer nums at most once. Formally, blah, blah, blah. Okay. What it means really is you can think of the array as wrapping around. So you can go, for example, 1, you can go to 1, -2, 3, -2, and then really -2 is followed by 1, and so on. Now these examples are not good. They don't really illustrate the wraparound. They don't illustrate the circular subarray at all. The only one that's possibly useful for explaining the solution is going to be example 3. But what you can't do in this last paragraph, really what it's saying is what you can't do is just keep wrapping it around, indefinitely. You can't wrap it around so that any given element is included more than once in the solution. But another way to think of a maximum circular subarray that may wrap from the end back to the beginning is that possibly the solution is going to include numbers from the beginning of the array as well as the end of the array. And then there'll be numbers in the middle that we don't use. And that would really be a minimum subarray. So if we can find a minimum subarray, then we can find the maximum circular subarray. Now, it's still possible that the maximum subarray is not a circular subarray. So we got to do two things. We've got to find the maximum subarray, which is what we did in the last exercise. That uses Kadane's algorithm. We can also find the minimum subarray. And for that, we can also use Kadane's algorithm sort of in reverse. So you find the minimum subarray and subtract it from the sum of all the numbers. that'll give you the maximum circular subarray. And then we can see which one is greater, just the maximum subarray or the maximum circular subarray. Okay, so there's actually, we can actually reuse some of this, I think. I'm going to grab that and I'll put it over here. Yeah. Whoops, too many. Oh, come on. All right. And then let's think about what an implementation of this might look like. So we have the local max, but we're also going to have, because we're going to find the maximum subarray and the minimum subarray. So local max, we are also going to have local min. We'll have global max, and we'll also have global min, and we're also going to have to keep track of the total sum, because the total sum actually starts at 0. To get the maximum circular subarray, we subtract the global min from the total sum. The minimum subarray from the total sum. All right. So for I equals 1, we've already handled the first number. I is less than, is it still called nums? Yes, nums.length. Local max equals math.max. Whichever is greater, the number that we're looking at or the number plus the current local max. You could refer back to the previous video, for a more detailed explanation of this. If local max is greater than global max, then global max equals local max. Okay, good. Now we have to do the same thing for the min. So we'll say local min is math min of the number that we're looking at, or the local min plus the number that we're looking at. And if local min is less than the global min, then we'll assign the local min to the global min. And we'll also keep a running total here of the total sum. Oh, wait. Oh, no, if I do it that way, no, so the total sum would actually have to equal nums 0 also. Okay. Now, let's do this. We're going to have two sums here. We're going to have the normal sum and the max sum. So let's say, I think it's good to give it another name. If we keep calling it max sum, it may not turn out to be the max sum. So let's say the normal sum, that is the non-circular sum, equals max global max. And we'll say that the circular sum equals the total sum minus the global min. Okay? Which one is bigger? Now, here's where this example 3 may come in handy. I mean, what we want to do is we want to say this. The global min should not equal the total sum. And if it does, that means that something like this has happened, where all the numbers are negative. So the global min of this is just, keep adding up all these negative numbers. So the global min is going to equal the total sum, in which case the max is going to be the normal sum. In this case, it would be negative 2. So let's add a test for that and say if global min minus, if global min equals total sum, then we'll return the normal sum. Right? Otherwise, we'll return whichever is greater. The, why do I have parentheses around that? The normal sum or the circular sum. Okay. Is there anything else I need to do with that? I don't think so. So we've used Kadane's algorithm twice to get a maximum subarray and a minimum subarray. We subtract the minimum subarray from the total sum to get the maximum circular subarray, and then whichever is greater, the normal sum or the circular sum, we'll go ahead and return it. Let's try and run that. Compile error, total sum plus equals, cannot find symbol. Oh my God. Yeah, it's not array, sorry. It's nums. Anything else? Okay, let's run it again. Oh, accepted, good. All right. And submit. Later. Okay, I'm kind of surprised the way that spread out. But there were a number of things listed under topics that we didn't do, like Q, monotonic Q. What was the other one? Divide and conquer. So it's possible, and I'll leave that as an exercise for the reader, that there is some more efficient algorithm somewhere in that list. But because this was listed in the Kadane's algorithm category, we used Kadane's algorithm to solve it. Anyway, that's it for the circular subarray. I hope you enjoyed it. Please feel free to like, subscribe, comment, and see you next time.